Okay, today we're going to talk about how to graph the sine function. So we're going to spend a lot of time with graphing after today. And one thing you can do with graphing this for the very first time, sometimes it's sine of x, sometimes you'll see sine of theta. They mean the same thing, but given the various angle measures, using the unit circle, we can find a graph. Now, it's been a while, but let's take a look at the unit circle in general. So if I just drew a quick unit circle, this coordinate point here would be 1, 0, right? And this would be our x, y. Now, the 90-degree angle measure would be 0, 1. The 180 degrees would be -1, 0. And 270 degrees would be 0, -1. We're going to use these 4 points, and really those 4 points only, to help us graph the sine function, the cosine function, the tangent function, and we'll see how those functions help us graph their reciprocals, cosecant, secant, and cotangent. Now, with this, how does the unit circle help us? Let's talk about what about when sine is 0. So at 0 degrees, or 0 radians, we're going to use radians for graphing. What is my sine function? Remember, sine is your y value, so I'm only looking at the y values. We'll look at the x values with cosine next. But the sine of 0 degrees is 0. Notice how my y value at my initial side at 0 degrees or radians is 0. So we have a point here at 0, 0. One thing that's kind of nice to know is to remember that sine starts at the origin or at your midline. We'll talk about what midline means later. Then, as I go around the unit circle to my next tick mark, right here, this is represented technically by pi over 2. So as I label my x-axis, and I go around my unit circle, here's pi over 2, or 90 degrees. What is the y value at pi over 2? Well, it's 1. So I'm going to label this as 1 and -1. As I continue around to 180 degrees, or 1 pi, I have my y value is at 0 again. So notice how the sine function starts in the middle, it hits the maximum, and it comes back down to the middle, or what we call the midline. As I continue around now, my y value at 270 degrees, or at 3 pi over 2, is down here at the minimum, which is -1. And then finally, as I make one full rotation, one full period where the pattern will start to repeat, I get back to my midline where my y value at 360 degrees or at 2 pi is back at 0. So this shape right here, this is representing the sine function, and that's a length of 1 period. After that, it's going to continue to repeat. Okay, now what about this? Why even give the left side or the negative side to you? Well, let's take a look at this. We'll see how the pattern is going to be continuous. It's going to continue on, and we're going to graph what we call 2 periods. So we have 1 period on the right, and we're going to have 1 period on the left. Now, how do I do the unit circle with this? Well, remember, if I start my initial side at 0, and I go clockwise, that would be negative angle measures, right? So if I go -90 degrees, or a negative distance of pi over 2, so at negative pi over 2, sorry, it's negative, we have a y value at -1. So this is going to be down here at -1. And then at negative pi, if I continue around to -180, we have a y value at 0. And then at -270, or -3 pi over 2, if I continue around, so -3 pi over 2, I have a y value at 1. And there is a good pattern here. If I go -2 pi all the way around, one revolution, I have a y value, again, back at 0. So -360 or -2 pi. So let's connect these. So have midline, maximum, midline, minimum, midline, continue on, max, midline, min, midline, and that would go on forever. We don't have to stop here. With the sine function, we're going to talk about how we can stretch this, shrink this, move this up and down. We'll look at what happens if the period length changes, if the amplitude changes, and we'll talk about all those terms in future videos.